For nearly half a century, Voyager 1 has been traveling through the unknown, drifting farther than any other human-made object has ever gone. Launched in 1977, the spacecraft continues its lonely journey into the depths of the cosmos. But recently, scientists have been puzzled, and even unsettled, by the strange signals it has been sending back to Earth. Signals that don't seem to match what's really happening on board. The twin probes that changed everything. Voyager 1 didn't begin its mission alone. It has a sibling, Voyager 2. Both were designed to take advantage of a rare alignment of the outer planets, an event that only happens about once every 176 years. This alignment allowed NASA to plan a grand tour of the solar system, where the spacecraft could use the gravity of each giant planet as a slingshot, propelling them from one world to the next with minimal fuel. Voyager 2 was the first to launch on August 20, 1977, from Cape Canaveral. Just 16 days later, Voyager 1 followed. Despite launching later, Voyager 1's faster trajectory soon allowed it to overtake its twin. From that point on, it became the leading edge of humanity's journey into the outer solar system. The first encounters in 1979, Voyager 1 gave humanity its first close-up look at Jupiter. It sent back thousands of photographs, revealing the planet's swirling storms in greater detail than ever before. One of its most stunning achievements was capturing a time-lapse of Jupiter's massive Great Red Spot rotating in real time, a storm that has raged for centuries. The probe also discovered faint rings around Jupiter and two new moons, Thebe and Métis. Voyager 1's next target was Saturn. In 1980, it flew past the gas giant, revealing intricate details of its rings and discovering even more moons. Most importantly, it made a close pass by Titan, Saturn's largest moon. Titan's thick atmosphere of nitrogen and methane fascinated scientists, making it one of the most Earth-like worlds in the solar system. This close approach to Titan determined Voyager 1's path, sending it upward and away from the plane of the planets, on a trajectory out of the solar system forever. The pale blue dot. After finishing its planetary encounters, Voyager 1's mission was extended. In 1990, at a distance of 6 billion kilometers, it turned its camera back toward the inner solar system. In a single mosaic, it captured a family portrait of the planets, including the now iconic image of Earth, a tiny speck of light, a pale blue dot, suspended in the darkness. That photo became a symbol of both the fragility and uniqueness of our world. Soon after, its cameras were switched off to save power for the long interstellar voyage ahead. The edge of the Sun's domain. Voyager 1 spent decades traveling outward, past Pluto's orbit and into the frontier of the solar system. Finally, on August 25, 2012, it crossed the heliopause, the boundary where the solar wind from our Sun can no longer hold back the interstellar medium. This was the first time a spacecraft entered true interstellar space. NASA confirmed the achievement in 2013, making Voyager 1 humanity's first emissary to the stars. Today, it drifts more than 14.5 billion miles from Earth. Its faint signal takes nearly 21 hours to reach us, and another 21 hours for our commands to return, making every adjustment a two-day conversation. The strange data for most of its journey, Voyager 1 has been in surprisingly good health. Its instruments have continued to measure cosmic radiation, plasma waves, and interstellar particles. But recently, engineers noticed something troubling. One of its most critical systems, the Attitude and Articulation Control System, began transmitting data that didn't make sense. This system is vital. It keeps Voyager's antenna precisely pointed at Earth, ensuring that we can still hear its faint transmissions. If it failed, contact with Voyager could be lost forever. Yet here's the strange part. Although the system's readouts look garbled and inconsistent, the spacecraft itself seems to be fine. The antenna is still locked on Earth. The instruments are still collecting data. Commands from NASA are still being carried out. Everything works, except the telemetry, which insists something is wrong. Normally, an error like this would trigger Voyager's safe mode, a protective state designed to keep the spacecraft alive. But safe mode has not been activated. Voyager seems unaware of the problem, quietly, a technical glitch, or something else. When NASA engineers first noticed the unusual data coming from Voyager 1, they were cautious but curious. The spacecraft was sending back information from one of its most vital systems, the Attitude and Articulation Control System. This is the part of the probe that ensures its high-gain antenna remains perfectly locked on Earth, across billions of miles of space. Without it, communication would simply be lost. At first glance, the data didn't make sense. The readouts suggested that the system wasn't functioning properly, yet the spacecraft was clearly still alive and well. It continued to receive commands, respond to them, and transmit scientific measurements as if nothing were wrong. The antenna was still aligned, the instruments were still working, and the probe was still faithfully carrying out its mission. But the telemetry, the spacecraft's own internal reporting, insisted something was amiss. Suzanne Dodd, project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory, explained that the most likely explanation is technical. Perhaps an aging circuit is misfiring, or a data pathway inside the probe has become corrupted. Voyager was built in the 1970s, long before today's robust computers and error-correcting systems. It was never designed to operate for nearly 5 decades. Its original mission plan gave it just 5 years to tour Jupiter and Saturn before going silent. No one expected it to still be working in the 2020s. And yet here it is, still functioning, still speaking, on hardware with less computing power than a modern digital watch. But while NASA insists the anomaly is almost certainly technical, the strangeness of it all sparks the imagination. Each Voyager probe carries a golden record, a carefully crafted message from humanity, etched in copper and plated with gold. The record contains music from many cultures, greetings in 55 languages, natural sounds of Earth, and images representing our world. It was intended as a time capsule, a calling card to any intelligent life that might one day find the spacecraft. So when Voyager starts sending home data that doesn't quite make sense, it's easy to wonder, could something out there have noticed it? Could the strange signals be the result of an encounter? NASA dismisses such thoughts as speculation. But the timing feels uncanny. A lonely spacecraft, beyond the reach of rescue, whispering back to Earth in ways we can't fully explain. The challenges of distance working with Voyager is unlike working with any other spacecraft. Its distance is so great that light itself takes almost a full day to cross the gap. A signal sent from Earth takes about 21 hours to reach Voyager 1. The spacecraft processes the command, then its reply takes another 21 hours to return. A single exchange requires nearly 2 days of waiting. This means that even simple troubleshooting becomes a drawn-out process. Engineers cannot simply send a string of rapid-fire commands and watch the results in real time. Instead, they must be patient, thoughtful, and precise. Every instruction must be carefully crafted, because mistakes take nearly 2 days to reveal themselves. Then there is the matter of power. Voyager runs on a nuclear power source called a radioisotope thermoelectric generator, or RTG. It converts the heat of decaying plutonium into electricity. But with each passing year, the amount of power decreases. To keep the spacecraft alive, NASA has already turned off non-essential instruments one by one. The cameras, the tape recorder, the heaters for some systems, all have been silenced in the name of survival. Even with these sacrifices, the clock is ticking. By the 2030s, the RTG will no longer be able to produce enough power to operate any instruments. Slowly, Voyager will go silent. A legacy that will outlast us. Yet whatever the outcome of this current mystery, Voyager 1 has already achieved more than anyone dreamed. It revealed new worlds, moons with volcanoes, rings of ice, and giant storms. It crossed the edge of the sun's influence, venturing into interstellar space where no probe had gone before. It has measured particles and fields in the space between the stars, giving us a first glimpse of the environment our solar system drifts through. And when the last bit of power fades, Voyager will not die in any ordinary sense. It will continue its journey. For billions of years, long after the sun has expanded and Earth is gone, Voyager will still be out there, an eternal traveler drifting silently among the stars. Even then, it will carry the golden record, a fragile, human-made artifact telling the story of who we were. It may never be found. Or, perhaps someday, far in the future, another intelligence might stumble upon it and learn that in one corner of the galaxy, there once lived a species that longed to reach the stars. A final echo. The recent anomalies may unsettle us. They remind us how fragile Voyager really is, an aging probe built in another era, operating at the very edge of what is possible. But they also remind us of something profound: Voyager is still alive. Against every expectation, a small spacecraft launched in the 1970s is still sending its whispers back across interstellar space. And in those faint signals, whether garbled or clear, we hear not just a machine, but the echo of humanity's greatest adventure. A journey that carries our curiosity, our questions, and our hope into the infinite.